Topic that a lot of people are talking about at the moment. What do you think about global warming? Do you think it's a real thing? Do you think it's just made up by the media?
I think it's a real thing. I think it's blown out of proportion.
I just believe that global warming is just a made up thing.
I don't really know what to believe.
It's a natural change too from the end of the last ice age, apparently.
There's a cycle of everything.
I'm not really sure because I don't really watch the news.
I think it could always do more. Probably don't want to, overplay it and concern people too much.
I think we've got time. I mean, it's probably something that doesn't want to be ignored.
Like, it's not getting that hot around here, is it? Temperature's pretty consistent all the time, every year.
Throughout the Earth's history, there have been many natural cycles caused by volcanic action, ice melt, solar flares and changes in the sun's output, and by longer-term changes in the way in which the Earth travels around the sun. However, if something else is going on, we need to act. I was asked to get to the truth of the matter. I read just about everything that's been written about climate change recently, and threw out anything that was based on opinion or speculation or used flimsy evidence. The single most important set of evidence came from the United Nations Intergovernmental Panel on Climate Change, their fourth set of reports published at the end of 2007. These have 450 lead authors, 850 contributing authors, and were reviewed by over 2,500 experts. This fourth report has been accepted by all academic bodies and all countries as being a true and accurate description of what's happening with climate change. Let me cut to the punchline. Climate change is real and it's caused by us. Consider this table. The blue band is the temperature we should be experiencing. This is our position in the natural cycle. Scientists can calculate this by taking into account volcanic activity, solar flares, and all the other contributors to climate variability I mentioned before. These have not had a significant global heating effect for the past 50 years. The red line is the actual temperature. This is the temperature increase we have caused. This table confirms it is a global issue. Our world is heating, and this will cause the kind of climate change that will not self-correct. It will continue to get worse. Let's get an understanding of the science of global warming before we go too far. The sun beats down on the Earth, delivering light and heat. Some of this is reflected back into space. However, some of what is reflected out is trapped and bounced back to Earth by greenhouse gases. It's the amount of heat trapped by the bounce that creates global warming. If there were no greenhouse gases, then too much heat would escape and the whole planet would be under kilometers of ice. A little bit of these gases is good, and a concentration of about 200 to 300 parts per million have given us the climatic conditions that have sustained life as we know it. Let's think about that concentration for a moment. Let's picture one Lego block as one molecule. 1 million Lego blocks clipped together, one on top of the other, is the same height as 22.5 Empire State Buildings stacked together. That's taller than Mount Everest. But the amount of greenhouse gases would only be this high, 300 Lego blocks, about the height of a basketball hoop. And almost all of this would be carbon dioxide. These are impressively potent heating agents, and just a small change in their concentration can have significant effects. While there's a basket of over 30 greenhouse gases, let's consider the three most important: carbon dioxide, nitrous oxide, and methane. Carbon dioxide gets all the attention because it's the most plentiful and has the greatest overall effect. It took almost 200,000 years for carbon dioxide levels to increase by 100 parts per million. Between 1850 and 1950, concentrations went up by 30 parts per million. Even more suddenly, between 1950 and today, concentrations have increased by nearly 80 parts per million. The recent rise is a straight line. The same story applies to methane and nitrous oxide. However, methane is 60 times more potent as a reflector of heat than carbon dioxide in the shorter term, and 23 times more powerful in the longer term. Nitrous oxide is 296 times more powerful than carbon dioxide, so these are important greenhouse gases. To use our Lego illustration, These 3 blocks in that stack of 1 million represent the total amount of methane and nitrous oxide in the atmosphere. That's just 1% of all greenhouse gases. And yet methane gives us 15% of the entire heating effect, and nitrous oxide gives us a further 8%. As the greenhouse gas's job is to reflect back heat, you'd expect that the temperature would rise as their concentrations increase. And that's exactly what's happened. 11 of the hottest years on record have happened in the past 12 years. The days are hotter, the nights are warmer, and the summers start earlier and last longer. This doesn't mean that the world will heat year after year in a regular pattern. The climate overall and the local weather on the ground is too complex for that kind of linear progression. There may be cold winters and milder summers, but as long as the greenhouse gases keep rising, the overall trend will be unstoppably upwards. There are 2 different but interrelated effects that are produced by global warming. The first and most obvious of these is the melting of ice left over from the last ice age at our poles. The most dramatic story of ice melting is at the Larsen B ice shelf. What we're looking at here is a NASA photograph taken on the 31st of January 2002. The crinkly bit is the landmass of Antarctica, and the white part is floating sea ice. Now, the sea ice is 220 metres thick. It is between 400 and 12,000 years old, and it covers an area of 3,250 square kilometres. Here it is 35 days later. The stability of the whole region is being called into question. This was a real shock to the scientific community, as no one knew that ice could melt and break up that fast. On the other side of the globe, the story of ice melting is even more troubling. The great expanse of sea ice at the North Pole has experienced a 1-degree rise in temperature per decade, which is reducing its size by 7 to 9% every 10 years. It is possible there'll be no summer sea ice left in this region in the next 20 to 40 years. It is not just these old, ancient blocks of ice that are reducing. It is also the newer, younger areas of snow and ice that are affected. Around the world, glaciers are retreating. This is a problem for the 1/6 of the world's population that is supplied with fresh water from glacial and snowmelts. For example, cities in Ecuador, Peru and Bolivia are almost entirely reliant on meltwater from the Andes. The Himalayan glaciers feed 7 of the great rivers of Asia, supplying water to over 2 billion people. And densely populated areas like California, Washington and Oregon rely on snowpack to sustain their river systems. For a large percentage of the world's population, it is not overhead rainfall, but rather distant meltwater that sustains life. The sea is also rising with higher tides, more severe storm surges and frequent flooding in low-lying areas. This is happening for 2 reasons. The first is thermal warming. The sea absorbs over 80% of the heat added to the climate system, and as the sea gets hotter, it expands and so takes up more space. The scientists are confident they can predict the effects of thermal expansion and estimate that it will raise sea levels by between 0.5 and 2.5 metres. This is a gradual process taking several hundred years before the full effect is experienced. What the scientists can't be sure of is if, when and how fast the ice on top of the land masses of Greenland and Antarctica will melt. Between the 2 of them, they could raise sea levels by at least 12 metres and could do so in a much shorter time. Because the science of this kind of melting is not agreed, it's largely left out of the IPCC calculations. But we should not forget that 23% of the world's population lives within 100 kilometres of the sea. Cities like London, New York, Mumbai, Tokyo, Shanghai, Bangkok, Jakarta, Seoul, Lagos and many others are less than 3 metres above sea level. There are already a number of Pacific islands that can foresee the time when they'll be unable to support their populations. In all these cases, just a small rise in sea level translates into deep floods during storms.